So as an introduction, we're fortunate to have JB Pauline here with us, as always at Neuroacademy, I believe. One of the reasons that we're fortunate is that he offered to talk a little bit about data sharing. JB's group is at the very cutting edge of data sharing. So if you think you know about data sharing, I think they're about to blow your mind here about all the possible ways in which this can happen. With that introduction.
Thank you so much. And I am fortunate to be here. It's a fantastic week. Yeah, so this talk should probably, the running title should probably be something about data sharing, because you'll see that's okay. And I'm going to, and Michelle is going to chime in showing some aspect of data sharing, and actually it's a bit more than data sharing itself. It's also like how do you organize your processing aspect, so she'll be giving a part of that talk. It's a small crowd. Please interrupt and make a discussion. It's so much easier to have a discussion than to have a formal talk, and also it's a little bit of a like a last moment talk as well. So. I guess that's not what. Okay. So the arrow doesn't work, but the click does. So I guess one of the aspects of that talk is why do you want to invest time in actually building infrastructure or doing data sharing? I think, and to that, there's I've got a couple of examples. I mean, you probably had some in the week before, but I've got a couple of examples I'd like to show you. One is about the problem of what is called dataset shift. And you heard about from Russ and others, like the reproducibility issue. A big aspect of the reproducibility issue is actually that when you're doing, like some statistics of some machine learning or some, like prediction on a specific data set, it's very rare that it would actually work well on another data set. And that's called the data set shift or distribution shift sometimes. It's, it's got various names in various, area of science, but the problem stays the same. And this is an example from a postdoc of the lab who actually was using the UK Biobank. That's a lot of data to predict maybe smoking status or depression status or this kind of things. And using either very simple learners or complex learners. But in any case, if you learn on a population, on a certain demographic population, like let's say the young subjects, young in the UK Biobank, are not very young, but let's say younger, and then you're trying to predict on the older subjects, you see a shift or a loss of performance of those learning algorithms, and that's just because you're not actually learning on the same thing. So when you're seeing examples of good learning in the literature, you always have to think, okay, are those things? When first of all, there's the trend and the test set, of course, and all those cross-validation issues and data leakage and all those things. But also, did they use many different data sets coming from different places? And that is a very different problem, a much harder problem. And if you want to think of the utility of those things, especially for patients and the things like that is what is required. That is what is actually useful. So data set shift. So making data sets available that are coming from different places around the world is a super important problem. It's a super important. So that's one of the rationale of that that kind of work. A second rationale, and more something that is going to be targeting what Michelle is going to talk about, is and also has been said, like I think Russ mentioned that as well, is what I call analytical flexibility. People also call that analytical variability. But anyways, the thing is, you use a pipeline for I don't know, doing some segmentation or doing some pre-processing or and then there's 3 or 4 other pipelines of that kind. And you have no idea which one is actually the best. So the one you're going to use is the one that the lab is using, or that's one possibility. Or the second possibility is this is the one that paper that I'm going to work on or has been I'm building on is using. That's the second possibility. But never, or almost never, you would think, okay, what is the principle of why I should use this one rather than this one? Okay, and that's and because all they have been kind of validated in the literature. There's no like kind of benchmark for your specific data set and so on. In this paper, for instance, Nikhil looked at the correlation between brain regions, volumes, or cortical thickness across the brain. Like, so that's the connectome, like sort of like a correlation for connectome, across subjects. And if you're using ants, or if you're using civet, or if you're using free sulfur, or FSL, you find very different results. And I can show you even more scary, pictures of that, where you look at the volume of some structure, structure in the brain. You look at the volume with on one axis you've got one pipeline, on another axis you've got another pipeline. Both very validated, extremely well established pipelines. There's almost no correlation. Correlation 0.3, 0.4. It's something like like you're thinking, okay, what is going on? And what is going on is that that's, I mean, okay, I won't go into why that is the case, but basically there's different assumptions, different algorithms, there's plenty of different, things. At the end of the day, results can be very different across pipelines. That's another thing that why, and that's a big problem in, I think, one of the cause of reproducibility issues. And that's why, working on infrastructure that help at least investigate that problem, or maybe possibly use that problem to actually do better things is important. The last thing I want to say is, let's say you have an article. So we've worked on an ecosystem to actually extract information from articles, and that's and often what you have in the article is we've used 70 subjects of that kind of demographic and that disease, and from it like that. Good luck, and most of the time you won't have access to the data. So most of the time you're going to think, okay, how do I have access to that kind of population if I want to, replicate or build on the top of that thing? It's a super hard problem. You're going to go on Google, or you will have, okay, can I search on Open Euro? Can I search on are those things kind of equivalent things in the UK Biobank? So you have in your mind maybe 10, if you're really good, like 20, if you're very, very good, like maybe 50 data sets, that you have, you can kind of like searching monthly on those things, right? So it's one motivation is at least if we were to be able to actually have a general system to look for those things, we will be much better off in terms of trying to replicate or to or just to build larger cohorts. One of the example that I'm not showing here is that in a previous work we had a very small data set of essential tremor patients, and those patients are very specific. They were coming only from this one hospital, thing like that. The only thing we could do is to find the control cohort of the same demographic. Hello, yeah, if you can mute yourself. Of the same demography, and then have a large control cohort, and at least there is a bit of more powerful aspect of the statistics, if you have those cohorts. So those are kind of a motivational kind of 3 slides for motivation of things. The second thing I'd like to say is that when you're going to look at data sets, most of the time those are in central database, in centralized database. And there are good reasons for that. First of all, it's much simpler. It's hard to do something else, I would say. Secondly, once you have a database established, and you have it's you have usually a way of sustaining that through either your institution or some grants and so on. It's much easier to manage once it's established again. And there's also it may be more like a sociological aspect to that. Once you have a big data set and you have a database, then you're recognized as a lab to have those data, and that, you know, it almost becomes like a bit of a business model for the lab to have a, you know, like a collaboration or possible grants or like even contracts with the outside world to, you know, using those data. Data sets in that case can be, you know, becomes like you know, an asset, not only for your reputation, but even potentially actually for your business, for your like, you know, funding sustainability aspect. So issues with centralized infrastructure, like, you know, go in Europe, and you just got the Damien's talk this morning, so I won't go into that, but I just repeat a couple of things that he's gone into many more details than I will do. The issue is that, first of all, you've got a lot of barriers for institutional barriers for using because of the ethics and the legal issues, right? And if you talk to the GDPR, there's no data sets from Europe that should be, I mean, I think there are a couple, but that should be on Open Euro, because Open Euro is in the US. The European data sets are governed by the GDPR. They can't cross the ocean, right? That's okay. So how do you search for the, you know, therefore, like, you know, those things? So the second thing is that governance. So if you have like a centralized database somewhere, there's a central place that governs that database. And, you know, it's not very clear often what is the governance and how is the governance, you know, like, you know, handled, and what are the rights and what are the kind of, if I'm putting some data somewhere, like an Open Euro on, or like, you know, on some other places, or, you know, any or things, what is my kind of a, you know, sort of a possibility of reaction if something goes wrong, or if I want to remove the data, if I want to update the data, if I whatever, like, you know, if something changes, and you know, like you're kind of giving away the thing, and sometimes it's perfectly fine, but there are many places that are worried about that. I'll give you an example that we've been working on with Nikhil and others in the lab, which is this big hospital in India that has like this fantastic data set. They can't push that on a US server somewhere, not for ethical or legal reasons, but just because if they do, you know, there will be an army of postdocs that are going to be mining those data, and then you know, they may have like, you know, a little acknowledgement at the back of the of the publication, you know, 3 years later, and they want that's to help them to build, you know, collaboration and scientific you know, interaction with others. And I think it's fair, like they don't have the resources to actually, you know, analyze those things properly, but they can't, you know, give them away. It's been like, you know, so much work and so much effort on their side, you know, so there's a little bit of a, you know, fairness in that sense, you know, that, you know, like that centralized database cannot handle properly often. There's the scalability issue. What happens is, you know, like, you know, Open Euro has a lot of means, but, you know, what happens if so much data is coming up, and what is the sustainability and the sustainability funding aspect as well. And then there's the lock-in syndrome aspect. Like, you know, let's say you choose an infrastructure for, like, you know, putting your data in, you know, the first thing you should ask yourself is, how do I get away from it? If I need to, if that becomes too expensive, too problematic, how can I, you know, get away from it? And if you have your, you know, your data set as a file system, on a file system in bits, there's no problem with that, you know. But if you have them in I don't know, like some company database, and you know, and then suddenly the fees are going by 20%, and the lab doesn't, or the brain imaging center doesn't have the you know, the means to sustain that, how do you get out of that? So that is one of the first thing that you have to think about, is the governance, and, you know, how that, you know, goes in the long term. I don't want to say much about the legal and ethical aspect, because again, Damien has done a superb job, and it really is worth, like, you know, listening again to what he said. But just a reminder that ethics are not 0-1 thing. You know, this, you know, it's not like, you know, the use is ethical or not ethical. It's like, you know, it's all that gray area that is difficult to, but pointing to, I don't think Damien mentioned that the open brain, it really starts with the consent, and again, it's not the only fair use of data. Consent is not only the fair use of data, Open brain consent is one of those really cool projects that will help you to choose an open consent if you need to, spread the word, for, especially for those who are acquiring data in your institutional labs. Brain imaging data is health data, is personal data. There's no way we can there's always going to be someone capable of getting so there's I don't think we can treat health and those data as anonymized at all. There's no way, and as Damien was saying this morning again. The legal aspect, interestingly, is not 0-1 either, right? Laws are, first of all, they are local. Okay, so that's and that's regulation from your institution, but also laws from your state or your country. Secondly, they are interpreted. So if Damien was showing you what a little paragraph or a sentence in the GDPR, this is an interpretation that is being done by a lawyer. That whether that something is legal or not. And often I was trying to point to that question, it hasn't been tested in court. So you actually don't know, what is the correct answer, because there's no correct answer. It's an interpretation of a sentence in a legal document, which is no. But the thing that and we're discussing that with Ariel, often institutions are very risk adverse. So what happens is that the people who are deciding whether something is possible or legal or not are people that are at the institution. They're not really in research project, or they're not. They may be like a data protector. They may be like the lawyer of your institution, or in various titles. Often, their main goal is to have the institution into trouble. So they're going to protect the institution. So if it's simpler for them to say no, that's not possible, there is that's not possible. And there's very little impact on them, and a lot of benefits. So I would say that there are exceptions, and University of Washington may be one, hopefully, but there are exceptions. But I would say that in many institutions and universities, the problem is that those the people that are telling you whether what you want to do is legal or not, or ethical or not, they are much better off saying no than saying yes, because they don't take any risk and they don't take any there's no impact on them almost. So that's except that you'll be going back at them and pestering them and things that's the only negative impact of that they may have. But otherwise their kind of incentive is not your incentive, and they basically want to protect the institution, and they are So that's and the other thing is that when you start to get the lawyers involved, it can take months, and months is a small, it actually can take years, so that's another aspect. It lasts often, it's not something that you can put into in factor in your PhD time, or you don't want to have that happen. So and generally speaking, I think I missed the quotation of that. This is a paper from I think a while back now, almost 10 years ago, and that paper was trying to assess how much data is actually acquired in, let's say, in neuroimaging, that is not shared, that is not seen at all, that you don't and there's capacity a little bit of doing that through mining of the literature, that you can try to see in the literature how much is that those kind of a classic data set, or how much is like a local data set that is not being shared, despite the progress and the recent progress with the NIH mandate and all those things. And I think it doesn't matter how much. I think the answer is a lot. And I think that's the problem. We many data sets, especially in the kind of a clinical research setting, where these are patient data sets, and most of them are not shared, either because ethical, legal reasons, maybe because there's a lack of technical capacity of the group, maybe because there's also I would say the asset aspect of it, so all those things, and the end result is that a very, very large part of the data set is actually the data set are not shared. And thanks God, there's very, very good counterexample of that, but there's this greater, like starting to be a good number of like very large data sets that are being shared, although some of the European ones are not, and the Chinese one either. But there's a good number of like a very large data set that are being shared. But there's a much long tail, larger long tail of data set that are not, because they are anyways, that's what has happened. And it probably costs a lot of money. It doesn't matter what this number is probably wrong, but I want to take a few minutes. Is that going to work, or do I have to switch?
Should be, but I don't know if I shared sound, so we might have to redo the screen sharing.
Oh, okay. Do you want to try?
Um,
So I'll take a couple of minutes to show you that little video, because I think it exemplifies a lot of the problem of data sharing. And I mean, it's a funny video. It's it takes I think 3 minutes and a half. It's worth watching. And if and let's see if we can make that work. And we can go and make it a bit faster.
Okay.
No, the sound is not.
No, I mean, it's.
DB9, I'm an oncologist at NYU School of Medicine.
Hello, Dr. Judy Benign.
I read your article on B-cell function. I think that I could use the data for my work on pancreatic cancer.
I am not an oncologist.
I know, but I think I could use the data for my work on pancreatic cancer. Do you have the data?
Everything you need to know is in the article.
No. What I need is the data. Will you share your data?
I am not sure that will be possible.
But your work is in PubMed Central and was funded by NIH.
That is true.
And it was published in Science, which requires that you share your data.
I did publish in Science.
Then I am requesting your data. Can I have a copy of your data?
I am not sure where my data is.
But surely you saved your data.
I did. I saved it on a USB drive.
Where is the USB drive?
It is in a box. It is in a box at home. I just moved.
But can I use your data?
There are many boxes. So many boxes. I forgot to label the boxes.
Hello again. Thank you for sending me a copy of your data on a USB drive. I received the envelope yesterday.
You are welcome, but I will need that back when you are finished. That is my only copy.
I did have a question.
What is your question? You might find the answer in my article.
No. I received the data, but when I opened it up, it was in hexadecimal.
Yes, that is right.
I cannot read hexadecimal.
You asked for my data and I gave it to you. I have done what you asked.
But is there a way to read the hexadecimal?
You will need the program that created the hexadecimal file.
Yes, I will. What is the name of the program?
Cytosynth.
I do not know this program.
It was a very good program. The company that made the program went bankrupt in 2007.
Do you have a copy of the program?
I do not use this program anymore because the company that made it went bankrupt. Maybe you can buy a copy on eBay.
I have good news.
You again.
I talked to my colleague. She knew a person with a copy of the software.
Then why do you need me? Everything you need to know about the data is in the article.
I opened the data and I could not understand it.
If you have the program, you will find it is clear.
Well, I noticed that you called your data fields SAM. Is that an abbreviation?
Yes, it is an abbreviation of my co-author's name. His name is Samuel Lee. We call him Sam.
I see. And what is the content of the field called SAM1?
Ah yes, SAM1 is the level of CXCR4 expression.
And what is the content of the field called SAM2?
That is logical if you think about it.
What is the content of the field called SAM2?
I don't remember.
What about SAM3? Is there a guide to the data anywhere?
Yes, of course. It is the article that is published in Science.
The article does not tell me what the field names mean. Is there any record of what these field names mean?
Yes. My co-author knows what the content of SAM2 is, and SAM3. And SAM4.
Can I talk to your co-author?
I'm not sure.
I would very much like to talk to your co-author.
Well, he was a graduate student. He went back to China 2 years ago.
Can I have his contact information?
He is in China. His name is Sam Lee.
I think I cannot use your data.
You could check the article to see if what you need is there.
Please stop talking now.
Yeah, so And it's probably like, there's clearly some aspect of that which is exaggerated or, at the same time, there's a number of things that are, I would say, where's the
green one,
the
no,
green
not
one.
the red, yeah.
not the right, that's the right one. So can you, before I move on to the next section of that talk, can you identify, let's say, 3 or 4 problems that have been said, in that little snafu thing? Yeah,
there's no data dictionary.
Data
which happens
dictionary.
a lot.
yeah, and that's a very important one. Yeah, absolutely. That's one. Anyone else? Yes.
There's only one copy of it.
Okay, the backup, the physical backup is definitely the second one. That they kind of it's again exaggerated, but who hasn't lost data, right? Okay. Yes.
The format of the data is hexadecimal.
Very good, very good. The format of the data is hexadecimal. It is no, it's not an open standard for writing the data in, and therefore, yeah. I think did I miss one?
Program, the program.
I guess the program and the format are a bit of the same problem, right? You basically don't have the okay, yeah. I think that most of those things are actually very real things. They're exaggerated a little bit in that kind of make it funny. But what's not that funny is that it's not too far off the a lot of the reality, unfortunately. So that's yeah. It's interesting. So the next part of that talk is actually to show you a little bit of what the direction we've been working on to solve for some of those problems. And again, there's no ideal solution, and there's no click and that's it. But this is and two projects that are kind of independent, but possibly can be linked in some ways. I don't know why it is. Okay, and the philosophy of the development of those projects is that we really wanted to have something that is lightweight. So again, if you're installing like a big database somewhere, it requires IT, it requires often it requires IT, but how much of IT is required is the problem, right? It requires means and it's a whole thing. Here we wanted to have much more lightweight, much more closer to the labs kind of a solution aspect, and also we use technology that are completely available but are not easy to actually grab and make that usable by others. I mean, that's the other aspect is that we thought, okay, if we solve one use case and then try to generalize, that's actually a much better way than trying to solve for the whole kind of a problem of the world. So we kind of focus on the sharing that on Parkinson and seeing if that is useful. So 2 projects. NiPoppy, Michel is going to talk about it, and it's and NeuroBagel is so NiPoppy is the local processing and organization project, and NeuroBagel is how do you connect data sets across the world. I mean, that's in a nutshell, that's what it is. So NiPoppy is more like, again, a protocol to organize your data, and it's not at all, and again, I'm preempting, but Michel will tell you more about that. It's actually more like, to me, in my mind, it's more like a protocol or standards than actually, and it comes with a tool and things, but it's more like a standard. How do you do a study that involves neuroimaging, but not only neuroimaging, and how do you organize yourself? And the NeuroBagel one is really like a tool for searching for decentralized data and possibly retrieve the decentralized data if you need to find a cohort of a specific demographic. So the challenges are the curation challenges. So how do you help people to adopt bits? The processing, how do you make sure that your processing is re-executable and you can have good provenance aspect? How do you make sure that those processing have actually succeeded in some ways, and are they, or is it? How do you manage that kind of a success or failure of processing? And that's NiPoppy aspect. And NeuroBagel is really the harmonization. How do you make sure that if you call that variable age, that is going to be the same as the age that is being called in another data set. It could be another data set from the lab next door, or it could be another data set, across the world. And then, how do you discover those data, across many different places? So within, like, if you have one data set, and if you want to process that data set, you usually want to have an answer of those kind of questions. How many participants with that diagnosis that are that age, and that has been processed with that sort of pipeline? Where are those data, and how many of those data do I have? Do I have enough to do that, like a study or not? And that can be done for like several data set, of course. But if you have several data set, then you have the additional problem of the SAM1, SAM2, SAM3 thing which is how do you actually label properly those variables? So it could be again age, sex, SSC, or any instrument that you've been acquiring on those data, on those participants, and how do you label those things in a harmonized way? And that's within an institution, but of course, if you have another institution, the problem gets not worse. Actually, pretty much the same problem, because many labs are pretty independent. They will do their things, independently of the labs, even within the same institution. But at least they could be on the same network. I mean, like that's so the way we kind of approach the problem is to actually use standards. So if there's that, only way we can solve for that is if we have an agreement of how we do things, or how do we name things. So the main thing that we're using in terms of the imaging is the bit standard, because that gives us meta information on where, what is a functional image, what is an anatomical image, and all those things. So that's the main standard that we are going to use for the neuroimaging data. But the data set is never only neuroimaging. It's always, other, data that are associated with those participants. And I think most of the cases, this is actually only useful when you have other data than neuroimaging. Like, it doesn't. So how do you use, what other standards do we have? Well, if you're thinking about diagnosis, there's a very good project called DOMAP that is has come up with the SNOMED cities ontology of diagnosis, and that has like hundreds of diagnoses, if not more, and it's a kind of a consortium across the world of agreeing on all those diagnoses, and how do you name them, and how do you know what's so they all have a unique identifier that are telling you this is exactly what is a Parkinson, or this is exactly what is a essential tremor, and so on. There's Cognitive Atlas, for instance, will have a lot of good is a good ontology for the instrument in terms of assessment, and that can be reused as well in that space. So the key thing is really not really what ontology do you use, but finding one that is solid, well maintained, and that has all the capacity of labeling your data in an appropriate way. So the way we solve the problem we're trying to solve the problem, at least, is to actually send a data model that has those URI, those kind of element of ontology that is describing properly the things in a graphical interface. So for instance, the problem that we have, for instance, in institution A, you have a diagnosis is in a column called DX, and there's those cells have like PAT control, CTL, PAT, and then in the other institution, the same thing is called group, and it's got 1, 2, and 0, and so what we do is help people to say, okay, here DX is actually diagnosis, and here group is actually diagnosis. And then, PAT is actually Parkinson's disease here, and that corresponds to 2 here in that column, right? So that's the problem to be solved. So the way it's done is actually to look at to have a data model, and then embed the data model into a little graphical interface that is running on your navigator locally, and then you have your Excel spreadsheet or your output of your RedCap or whatever infrastructure you have for your demographics and instruments and clinical variables. all the tabular variables, and say, okay, I'm going to paint, and I think I have possibly a little demo of that. Yeah, I'm going to paint and say, well, if that participant in my Excel spreadsheet is actually the subject ID, and that pheno age is actually age in my local data model, and so on. So what you do is actually you paint and you say this is it, and then when you've done that from the column aspect, you've got the column, then you go in the column, and then you say, oh, in the column maybe I have a diagnosis, and then this for this subject. CTRL is actually healthy control, okay? And then you do that for all those variables. It's actually not very long because you have to do it for the number of different things that you have. But it's not even if you have 2,000 subjects, that's not going to take very long because you may have only 3 or 4 things to actually annotate within a column, right? So that's what that thing does is simply to add to the bits data dictionary. It has some annotation, so I don't think it's very probably not big enough on that screen. But what the bits description has is a human readable thing. So you have age, description, age of the participant, which is great. It's already a big step forward to not having that, right? The next step is actually to have something that a computer can read and say, and that's the second part. So we add this little annotation in the bits description JSON file to say, hey, actually, that age, the label age is actually that term URL. And then you go to that URL and then you find the definition of age, exactly what is age. But that a computer can read. And that's how you can match things. So once you've done that, actually, I will. How much time do you have? I'm not trying to. 15 minutes. Once you've done that, you can actually have a little graph knowledge store if you want with just the metadata. Those metadata are so you point to that kind of a bits directory, and then you point to that data dictionary that you just created with that graphical interface, and say, okay, construct me a little graph knowledge, and then that little graph knowledge is represented here with those little graph nodes there, and then that is and that's using linked data technology that is very standard. That's a W3C standard. And then you can start to query those things locally. That's already interesting because locally you can actually start to answer, hey, how many subjects do I have that have those characteristics? But what the really interest is when you can actually query many nodes across the world. So let me show you. Do I have a?
Want to show the query as well?
Yeah, I just want a navigator. Is that?
I mean, you're in the navigator.
I need to escape. Okay.
Or I can open new possibly.
Actually, and you can actually do it on your computer now if you want, and we'll see if we can crash things or not. If you go on your navigator now and you type query.neurobagel.org. So try that. So that's what Michel just did here. So you go there, and I'm not going to show you until you do it yourself because I think it's more fun and see if things are actually working well. You go there, you have this, you should have this interface. So who has not this interface when you're going on query.neurobagel.org? Who has it? Everyone. Okay, awesome. So then the first thing you look at is the graphs. Okay, the graphs here. We're going to query all the graphs that we have, and there's one. It is the indie graph. From the Michael Greenham Institute. Open Neuro is another big one from a Rust Open Neuro project. And then we have as an example our own local Quebec Parkinson network in this. So let's say I want to query all the graphs. That's fine. I'll do that. And then I want, I don't know, who has an idea? Like maybe I'll take an example that I take some time because I want the subjects that are between 50 and 70 that are female. And let's say I want those to be Parkinson disease, so not atypical, but Parkinson disease subjects. And let's say I want one specific, I want at least to see one in those things, in those data set. And then you submit the query and you can try other things like, and then sometimes you won't get any answer because there's no data, but you submit the query and then you see that in that specific query, there's 3 subjects from that one open neuro data set that have, are female and Parkinson. Okay. And then from the Parkinson network, there's 70 subjects in that data set. And then you can select those things and see whether you can actually retrieve the data. You can actually download the participant level data and see. And if the data are on Data Lab, there will be like I don't know if that's already there, but at least there will be a link where you can actually go and do that. Data Labs gets that link and get the actual T1 of that things. And then if the data are not actually available, you'll get in that TSV file that you can download, you'll get a restricted access kind of thing. So at least it helps for the fundability and it also helps for the accessibility when the data are actually Data Lab data sets. Yeah, I'm really crippled with that thing. Is that not the?
Go back to the slides here. Yeah.
How do you switch from those things? Anyways, I should have looked at that before. Okay, so the other thing that is kind of important to understand is that we build that such that the security aspects are quite well done. So if you query, you have the graph in one container, and then you have the query tool in another container, such that if you want to tune a specific way of how your data set is going to respond to a query, you can say, hey, I'm going to say, that's, I can't answer anything else that yes or no have data on that, because that's a lot of the concern, that those of some, some hospitals, they can't actually give you even the metadata on sometimes on things, or the age or sex or things like that. They can't give you that. So, but they can say yes or no, I have data, and then help you access the data with a different kind of mechanism. Yeah, so that's the query that you can play with, and please do. And hopefully, I don't know how many people have crashed the other things. No one. All right, okay. So it is actually solidly working now, but you never know. So the control aspect is important, and by tuning that container that is actually the application program interface on the graph, you actually can implement some security level in your research, in the search. I think yeah. So we have a bunch of graphs, and some of them are completely open, like Open Neuro. This is CC0. You can actually retrieve the data and all those things. Some of them have some of those data that are more under control, or not being able to be shared and all those things, and some of them are completely not seen because they can't even show you that they exist on the network, but they have access to the open ones. So it's a very flexible and a bit of different mindset that of data sharing that was actually done, I think, in the past. The important aspect is that data are local, data stay local, and data stay under the local governance of the people that have and that are in charge of those things. So if you want to change any of the access aspect, or if you want to remove or add or things, this is a local decision that doesn't need to be like a transaction with a central place, and I think that makes a lot of people much more comfortable in adopting that sort of things and making those data more visible, more findable, and possibly accessible, because they stay in control. The governance is still local, and I think that's both like a ethical, legal, and psychological aspect to that is really important. Again, I've mentioned Data Lab. Data Lab is this fantastic tool, not a complex but fantastic tool that is based on Git, has expanded Git to not only the code and the ASCII files, but to binary and large files, and has embedded that capacity to have distributed backends of data in many places. So when the data are in data lab, we're using that data moving sort of a capacity of data lab to retrieve the data. So it's a fantastic project, which I really suggest that you look at and you study and possibly use it. It has a bit of a technical barrier, so it's you need to find a good use case that work for you, and that it's when it's working, it has fantastic capacity, not only, by the way, on the data sharing aspect and the data moving capacity, where you can say, hey, I don't know if you have data lab installed on. I have data lab installed on my computer. If I want to look at an open neuro data set, I would do data lab install // and then data lab install open neuro, and then I would go into one data set. I would install, and all those things will happen super fast, because data lab is just retrieving the metadata of those data set. And then when you actually want the data, when you can go into the tree of things, you can actually do the data lab get. That will take some time, because you actually will get the transfer all the data on your computer. It's a fantastic tool. So I would just say, I was just wanting to say, we are using it, and as much as we can. Yeah. There's a number of things that are being developed. First of all, annotation doesn't need to be entirely manual. If you have Google LLMs that can help you annotate automatically, so we have a little project doing that. And we also looking at authentication and authorization aspect using the GA4GH. The genomic world actually has solved for a lot of those problems a long time ago. I mean, they have, there's something called the beacon, for instance, where you can query a variant across hundreds of databases and things like that. It hasn't percolated. There's kind of a barrier in our kind of communities. So we don't use exactly the same technologies, but we're going to start to link with those technologies together. So, yeah, that's the beacon. So those are some of the nodes that we have. Most of them are, many of them are actually Parkinson nodes that we can search for Parkinson data, and so if you're interested in that, that's the capacity. I just want to end with some kind of a high-level thought on the infrastructures. And infrastructures are difficult object by nature, especially if you work in the science area. First, and they are noticed when they don't work. I don't know if you have your HCP or if you have yourself a database or things like that. And that's hopefully not too many people are German here. This is an example from the German German trends. Actually, I mean, my German friends are actually quite happy with those things, because they kind of rant on the German trend system. But so infrastructure, they are noticed when they don't work. That's one thing. And if you're using your HCP daily for things, you will start to forget. Let's say internet is maybe even better example. You open your laptop, you're here, and everything works, and you don't even think, okay, someone has put the internet, and that is completely past your only when that doesn't work, you say, okay, I don't have internet, what is going on? And that's a really kind of a characteristic of infrastructure. The other thing is that you have to be super careful when you choose an infrastructure, because they're super hard to modify, to maintain, and also to terminate. And I think that's one of the thing, for some of those things, thinking, how do I get away from them when I can't use them anymore, for some X or Y reason. So they're very hard to modify. And if you modify something, how many people will be affected, and maintenance aspect, all those things. So if it gets slow, and if they're and if you have to again to stop them, that's a very difficult task. they're also non-competitive space. Like if you have a, maybe the network is a bad area here, but let's say you have a cable that goes from one building to the other, you don't build another cable, you don't do another cable until, you really need to because of bandwidth issues or whatever. So, so they're not competitive aspect. So to finish that part of the talk, and I'll give Michel the floor, I would say that most of the people are thinking when they're building data sharing or processing infrastructures, they're thinking about implementation aspect, sustainability aspect. I would say governance, how those infrastructures evolve and who's deciding on the evolution, and also are almost as important, or if not more. The other thing that I think is key to me, at least, and many people, is that infrastructures are also an opportunity, and probably the only possibility of doing that properly is to build a community around that, because especially for the sustainability aspect, I don't want to be the one that is in charge of that and actually providing all those things for for a large community. It has to be like BIDS, like a community building some standards, and that is the way that can be sustained. So this is the classical bus factor for software development. I don't think you if you don't know, raise your hand, but if you know, we can go on. But I think the problem is really more like a lab bus factor. Like how many labs are actually going to be working on those things? And so I'll tell you one story. One story is the nylon, for instance. Many of us actually use nylon. There are many labs that are actually contributing to nylon. But for instance, I was lucky to have a CDI grant, and so I could actually pay for a nylon maintainer. And then, maybe next year I can't pay for that maintainer. Maybe Ariel will have a grant and will pay for an island maintainer. And next, the year after, maybe that's Ross in Stanford. Maybe that's Bertrand in Saclay. Okay. So having a network of laboratories that are interested in a common infrastructure, in a common, or like in that instance, a package, but like in something common is really critical to me. I think that's how we can sustain those things and make those things progress. The last thing is that we have to work with incentives, and I love that quote of Carol Goebel, which is there are 4 incentives, main incentives: love, fame, money, and rules. So love is the thing that you love to do and you would like to do, and that's maybe your PhD project or something that really interests you and something like that. Fame is unfortunately many people are interested in getting a lot of recognition, and that's one aspect that in academia at least is important, that people are want to get known and for things. Money is another incentive, and that can't be ruled out. And then rules, because maybe NIH is now forcing you to actually share your data, and before they didn't. And so those are the main things, and we have to work as a community with those things to make the best of our time and effort. Yeah, so that's it for this first thing, and then I will let Michel tell you a bit more on another aspect that we have been working on.
We want to do questions.
Yes, we want to do questions if there are questions. And if they're not, we can go on. Yes, please.
I have a question. Yes, thank you so much. It's so exciting to see the evolution of Neurohack. So I've been really interested in using subject level process data for an app that we're going to talk about in a couple of weeks.
Yeah.
Is there plans underway or currently happening to distinguish between the different levels of process data versus raw data?
Yes, yes, there are plans, there are things happening right now on that. There's two things are happening. There is, first of all, I mean, you will probably see more of that after the NIPOP presentation. That how do we extract automatically from a standard processing IDPs that can we put that in the neurobehavioral graph and then query on those things. At the moment, nothing prevents us to actually get into those graphs. Let's say instead of having like a T1 images, you would have free surfer 6.2 processed T1. That's nothing is preventing us. It's just we we can't put all the use cases in the world in a thing. So like, it's a step by step. And I think it also will be with the capacity of making the platform tailored for a specific use case. I think, there's maybe sometime, people will want to use that for specifically for EEG. And then for EEG, you will have like, variables that are really useful for querying EEG things, but are not very useful for querying like, MRI things. So I see that also as a possibility of building a community. If a community is interested in some aspects, of the data or some or derived data, for instance, then there's a little bit of a change in the data model, a little bit of a change in the interface if you want to. But that's actually quite simple because those processed data can be detected automatically. So it's not going to be a big effort in making this evolution. Maybe a much bigger effort if we have to rethink of the ontologies, and we have to rethink of the type of things that we can query on. Another aspect which I want to re-emphasize here, because it was not clear, like many of those tools that are linked data tools, people tend to annotate everything. There are many projects, I think I've been working on one that is for a long time, which is NIDM, where you tend to annotate, all those things that you have, and the goal is to have provenance on everything and annotation on everything. This is not what Neurobeagle is actually trying to achieve. It's really trying to achieve the query and the findability system. So you may have less variable to query on, and then you may be able to retrieve many more information, for instance, for like, a specific cohort or like a specific data set. So separating the data model or the variables that you want to have to query on and the annotation and the provenance of the data is, I think, is a very useful separation to do mentally, because it's often confused, and if you try to query on everything that exists and can be annotated, that doesn't work for different reasons. But okay. So I think yes, we are super excited by that branch of things that is developing. Yeah. So yeah, but not today, but hopefully tomorrow soon. Any other question people may have? Yep. Okay. Michelle.
All right, so hi everyone. JB talks a little bit about NiPoppy, but mostly about Neurobeagle. So I'm going to talk about the NiPoppy part. For a bit of context, this project started because within the lab, we had two different Parkinson's disease data sets that had both imaging and clinical data. And we wanted to process them with the same pipeline, same version, and organize them in the same way so that we could combine the results and do some joint analysis on it, which hopefully is something that people will do more and more to have more statistical power for analyses. And we quickly realized one big thing is that data sets can be very, very, very messy. Especially if, yes. And we spent a lot of time and struggled to just wrangle them into some usable form and to try to figure out, because we weren't the ones to collect the data, but sometimes that's also the case for data that you have collected yourself. So we spent a lot of time trying to curate them, to organize so that we could run the processing and then we can do the analyses. And then we're still not quite done with the analysis part. And that process is very time consuming to organize and to process data. And it has to be done. It takes manual work. You cannot automate everything because it requires specific knowledge about each data set, and they all have their own different quirks. So you need a human in the loop for it. But there are possibly still ways to facilitate the entire process. So the main question that we have is can we come up with a way that was to standardize and process data in a consistent and reproducible manner so that you know what you did, so that future you and also other people do not hate current you or past you. So we developed a framework. We call it NiPoppy because Neurobeagle was an existing project, and you're like, puppy bagels is kind of a thing. So NiPoppy is really, we think of it as a protocol for best practices following the FAIR principles. in organizing and processing of data sets. And the framework starts after the data collection step. So it really tries to remain flexible so that you take the data as they are, however they were captured, in whatever file format and however messy or not messy they are. And then the first step after that is to organize the data. And for this, it's really organization at the study level, because data sets do not only have imaging data, like JB mentioned. So for imaging, when you think of organizing imaging data, then hopefully one of the first things that comes into mind is BIDS. And BIDS is great. BIDS currently it's still like mostly imaging focused and is not really adapted for like whole study level standard specification, although we are working on that and kind of talking with the BIDS steering group. And so there's also like non-imaging data. And so we want to focus on tabular data, which can also be very messy and even harder to standardize because literally everyone has a different way of doing their tabular data. And then once the data is organized in some consistent manner, we want to process the data. And for this, ideally, it is in some reproducible way. So for reproducible processing, there are two components. First of all, for those of you who were at the Docker workshop earlier today, you have containers, and containers encapsulate all of the processing environment so that you can have portable pipelines and they can be run on different operating systems in a pretty much very consistent manner. However, when you run a pipeline, like for example, fMRI prep, you don't just do fMRI prep, here's my data, and then, well, you can do that, but there are also a lot of different command line options. So each pipeline has a lot of options. We've seen in previous days that pipeline parameters can change the outcome of an analysis by a lot or by not a lot. So that is something that is also needs to be captured and remembered. So maybe if you just write something on the command line and then it's in your bash history for a while, but then it disappears and then you don't remember what you did and then it's not written anywhere. So for this, and here instead of Docker, we have the Apptainer logo, but Apptainer is just another container engine thing that's used more commonly in HPCs because sysadmins like it a bit better than Docker because of security concerns. And there is this other logo, which probably you're not very familiar with, but this is a framework called Boutiques, which is in very general terms, a command line description framework. And I'll go into this a little bit more in more detail, but what it would allow you to do is to abstract away the command line arguments of a pipeline and to put them into a JSON file. And so then you can kind of keep that on your system in a text file that you could potentially version or have different files, and then it's still there, it's not ephemeral. And then when you process the data, usually it's not really a one-shot process, everything is done, there are problems or you have more data coming in. So one thing that we find very important is just a tracking aspect of how many participants has completed processing successfully. Like they have all of the files that I expect them to have or not, and then maybe I want to rerun the pipeline, the same pipeline, same container, same parameters on participants that have failed because maybe it was just like interrupted because my job was too short and it just got killed. Or maybe it's a ongoing study, there's new data coming in, but I've already started processing and then I want to process the new data in the same consistent manner. And finally, we have this extraction step, which is I have my pipeline results. I want to put them into a way that's like input to my downstream statistical analysis. Maybe that's a CSV table, something that I can load into pandas. Maybe it's something a little bit more complicated, and maybe this is something that I can easily share with other people. And the idea is that if different labs, for example, or just different people processing different data sets kind of follow some consistent manner, consistent protocol, and then sharing the data, then you kind of already know what it is, and there's it's more standardized, so then it makes everything downstream kind of easier. So this is just a summary. So we go from raw scanner data to IDPs, and there's also this dashboard, which we have developed to interactively look at data availability, which I mean, you can see this is also Neurovagal URL, but I'll briefly show this a bit later. And so this framework involves a data organization specification, but for both the imaging and non-imaging data, and also at the whole study level, because we really do think of it as kind of best practice protocol of, I have a data set, what do I do with it? That makes the data more fair. And finally, we have developed a software package with tools to help work with this framework. And I will do a little small demo of this soon. But yeah, I'm definitely happy to talk more about it. And we are also looking for people who are interested in working with us for this kind of thing, like JB has mentioned, for the sustainability aspect. So if you are interested, definitely come talk with us. I won't go into too much detail, and this is kind of an overview of how we're thinking of organizing the data. But I'll have this a little bit more in detail in the demo part. This as well, I think I'll leave it here just in case we share slides later on, but I can also just do show it live. Okay, all right. So I am logged into a server where I have basically a terminal window open that I call Neurohack Academy demo. Can people see? Is it big enough? Okay. So here I have a data set. It's called example study. You can kind of look at directory structure. Is the same thing that I showed earlier. I won't go into detail in everything here, but it's a very small data set because, well, it's just for showing what it's like. If I show what's in the bits directory, then I have already bitsified data. Although we do provide tools for helping to run existing bits converters. And that's something that maybe I should clarify, is that we don't develop pipelines. We just kind of make it easier for you to run for users to run any pipeline in a very similar manner. And this is what I'm hoping to show with this demo here. So I have a data set. I have one participant, one session. If I do ls in here, I see that there are two files, and they're kind of the bread and butter of the whole framework. There is this manifest file, which really is like the first thing that you should be creating for a data, is this manifest file, just for your own sanity, which participants and which sessions and what kind of data do they have. And that serves as a ground truth, so that when you check your bits data, you can ask yourself, well, do I have everyone that I expect in the manifest or not? Or do I have, for the process data, for my results, does everyone have process data or not? So I hope these are fairly straightforward to understand, but yeah, so I won't go into too much detail, but happy to talk about it later if anyone has questions. And now there is a global config file. This is for more of like processing parameters or pipelines that people want to apply to their data set. So some generic descriptives, and then for processing pipelines. And if, for example, I want to run fMRI prep on my data, then I would write a configuration, and I'll show there are defaults, and I will show kind of the command to create a new study directory. But here, importantly, we have the concept of each pipeline is identified by a unique name and version combination, just to have awareness that software has versions, and so that you can remember which pipeline has been run on the data. Ideally, things are containerized, although that is not strictly a requirement. And then there are parameters for running the container call. And then here, importantly, there are these two paths to two files. And this is related to the Boostix framework that I described earlier. There's an invocation file and a descriptor file. And the descriptor file is, both of them are JSON files. The descriptor file is an example here, for example, for MRIQC, which is the other pipeline that is for which I have a configuration in this thing. The MRIQC descriptor file says, and this can be semi-automatically generated, and it comes with the boutiques framework. They have a schema for like when you have a tool, then you can write a description for it. It needs to have these fields. So if you look at command line, and there are things like the bits directory, the output directory, and if you have run MRIQC or any bits app, this is kind of similar, hopefully, this is familiar. And then there are things like inputs, and it's a list, and it has bits directory, and it says the type is a string, and then the value key is bitster. So this is one part of the puzzle. And this descriptor is, there is one descriptor per pipeline. And so if someone has written a pipeline, they write a descriptor for it, and then they can send you the descriptor, and you can use it if you do one thing, and that is write the other file, which is called the invocation file. And here there's like common IDs for the keys of this is a key in the descriptor. And this is where you specify the runtime parameters of the pipeline, basically. Does that make sense? So if you can imagine that if we have these two files, then we can build a command line, and I'm going to show that in like 1 minute. And it's going to be able to run fmri-prep in my, or MRIQC actually, in my container, and then show you the command that it builds, and then everything is in text files so that you can, it is recorded. So I forgot to do one thing, was to kind of show how to initialize a new data set. So here I'm in my demo directory. I will activate my virtual environment in which I have NiPuppy installed. So it is, the tools that we develop is a command line interface. And there are several commands that you can see if you do -H, and it should not take that long to show. So several commands. We also have documentation website that is still in work in progress. But I think it's a good starting point if you want to learn a little bit more. So if I do NiPuppy init, and then I say dataset root, and say other study, then it will basically go and create all of these directories that I have shown earlier. It creates a sample global config, a sample manifest, just to show which columns are there. And now if I do tree command on other study, then it shows. And there are a lot of files that are copied by default for a lot of pipelines that we have worked with. So just shipped everything together, and we might change that in the future, but that's what it is currently. So now let's say I want to run MRIQC on my entire data set, which currently is only one participant. There you go. Well, I don't need to go in the example study, but then I can do NiPuppy run, and run means like run a processing pipeline. There are parameters, but there's only really one that is needed. So if I do NiPuppy run dataset root, which is current directory, and then pipeline, MRIQC. And I'm not actually going to run it because it takes a bit of time, but if I do use the simulate flag, it will show the command line that is generated. So here is what is built based on container-specific configurations that are in the global config file, but also here what is in my invocation and what is my descriptor file. And so this has also, I like the simulate option because I can check exactly where, if something goes wrong, then I can check this is the command answer, and I can just copy it and try to debug it like that. And then I have also a descriptor and a config and an invocation file for fmri-prep. And it's very similar. It has some paths, it has some template strings for like this participant in that session, for example. And this is explained a little bit more in the documentation. But on the command line, the only thing that I have to change is change pipeline name to fmri-prep. And it's gonna say, here is what I'm gonna run. Yeah. So, and this is a command for fmri-prep. And so with this, there is recording that if you have multiple versions and multiple different kind of pipelines and also custom pipelines, as long as you have the descriptor file, and you can, which can admittedly be a little bit tricky to write. So this is a little bit of the learning process. And we are working with the lab that develops boutiques, and maybe we can think of some ways to make this a little bit easier. There are semi-automated ways to generate that depending on how the pipeline is created, but I won't go into detail. But yeah, so I actually yesterday already ran MRIQC on my data because it took maybe 10 minutes, wasn't very long. So now if you go in derivatives and look at this, it's okay, there's a bunch of other directories that were created. Output, here's kind of what my output looks like for MRIQC. For people who don't know, MRIQC looks at, for example, your T1 image, calculates a bunch of metrics on it. It is useful for the large data sets, and it is more useful if you have more than a single image, because it's for like quick visual quality control, sanity check of like the distributions of all of those metrics, and if there are any outliers, for example. But so it creates this JSON file for each image, and then it creates this HTML report. And now I want to check, did MRIQC run successfully for this data set? And then the command for that is nycopy track. And then same thing, data set root here, and then pipeline MRIQC. And now what it's going to do is I have in another file defined what I consider as success criteria for to determine that MRIQC has completed successfully. So this is the tracker config, and it's just paths. So right now, this is what it's checking. Do these paths exist for this participant and for that session? And then it creates this bagel file. We call it bagel right now because the idea is that eventually this can be just inputted to Neurohaggle, although they are still independent project and you could create inputs of Neurohaggle using some other way. But if you look at this pipeline complete column, it says success. So for participant 3000, session BL baseline, I have successfully completed MRIQC. And then I have this other pipeline that I have defined in my global config that maybe I want to run on my data set. So I can also track, does this exist? Have I run fMRI prep successfully? And here you see fMRI prep version and then fail. And now I have this bagel file. If I download it to my computer, because this is the server here, and I go open a web browser, and I go to digest.neurohaggle.org. It is this dashboard that I briefly mentioned earlier. So now I can upload my own, here they call it digest file. We need to, talk a bit more about this nomenclature stuff, I think. And now I can, the data set, call it Neuro Academy. And it shows participant 3000, session baseline, fMRI prep fail, and success. So this is not super interesting because it's only a single participant. But we also have examples for the Quebec Parkinson Network dataset, which we are locally processing. This has more participants and more sessions and more pipelines that were run on it. And then there are some interesting graphs just for a quick check of, and it's very satisfying once you're like in the process of processing a data set to check how much green do I have. Sometimes I guess it can also be depressing if things have failed. But you can also filter by session of who has, so Hue the comp here is just really means bids data, who has success, whose data has been successfully converted to bids. And this table now shows 43 participants matching the filter out of, right, because, okay, the reason is because it's a longitudinal data set, but not everyone has the second session for now. So 43, and this can also be downloaded so that now you have a list of participant IDs and session IDs for basically participants who have BIDS data, but you could do this for other pipelines. So I think this is all that I wanted to show for this brief demo. But again, I'm here this week and next week. This is the wrong thing. All of this week and next week, like all the rest of us. So yeah, I'm happy to talk about this more. Hopefully this can be useful for some cases. I have a few, I think, 3 more slides. So big takeaways from this is that we are trying to do whole study level data management, but also processing and tracking aspect, and the extraction, but that is a little bit more in, we're still thinking about how to do this. Yeah, so if anyone is interested, we can definitely talk more, because I think it would be good to brainstorm. MRI processing for both containers and parameter recording, and then the output is either we can have derivatives right now, and also shareable dashboard, which is very nice to show. Maybe some supervising person here, I have design results, or we've had the case within the lab of like, we need to write some proposal. We need to know exactly how many participants we have and maybe their demographics and things like that. So that's been useful within the lab. For here an example that we have done. So again, Parkinson's disease data set analysis. We have 3 different data sets, PPN and then PPMI, which is stored at the USC, and NIMANS, which is the data set from Bangalore that JB mentioned before. And we have done some comparison of the free server IDPs across these 3 studies, and it's the same free server version, and everything was organized in the same way. This is still, I think, in preliminary stages and not really like the final analysis, but kind of use case of what could be possible and could, or to make that something that NIPOP could make a bit easier. And one thing that we are also interested in is that with this whole decentralized processing concept and framework, I think we've been discussing kind of federated learning things where you can train models so that you don't have to actually have all of the data in the same place and still be able to do analysis. And that's also, if anyone is interested, I would be interested to talk about this a little bit more, because it's also early stages kind of thinking, but potentially some projects or collaborations. Yeah, so this is just some other people that we are talking with for both Neurobagel and NIPOP. I don't know, JB, if you had anything to add, because the last thing is a thank you slide with URLs. So right.
Thank you. Just to add that this is a bit of a, I had the question of why yet another tool, like now there's BAPS, there's, a bunch of tools that there's Nodes. I think this is not yet another tool. This is really more like trying to make it a standard organization, and you can, have take part of it, leave part of it. It's more, again, it's more like, almost like a training aspect of how you do your processing study from A to Z, plus a couple of number of tools to help you on the way. But, it's and yes, it's also like it doesn't hide, it's not like a click and, or big thing that you put your data in and you have no idea what's going on, and then you get the results out. Like, it's really like, giving you the opportunity, the capacity to look at things, to like, check things, to like, this is, it's really a different type of object than the usual kind of I would say, monolithic data processing sort of software, if you want. That's a number of those. This is really like, I'm a PhD student. I've got to process that data sets. How do I organize the file system? How do I check? How do I do things? How, and as Michel was saying, there's no, I mean, I can even the data could not even be in bits, right?
Technically, that's
Technically,
true. Yes.
you could even not have bits data. So it's a very flexible kind of a framework, and it's not. It is a set of tools and set of guidelines. More than a monolithic thing. So it's a different kind of thing. I think we hope it's going to be useful. And again, if it's adopted enough, and it's starting to be adopted, like we have a bunch of people interested, Amsterdam, us.
Yes.
Having a standard way of organizing a study that is using it is going to be fantastic, because then then you can build tools on the top of that, and it's going to be so easier to achieve work collaboratively on things, and so that's the main idea, is to make that protocol / standard, on how to do things and how to organize things, and with some tools to help in the way. But some of it is actually a little bit technical, like, if you don't know how to do a boutique descriptor, that's going to be like, a barrier. But, I think we have already a bunch of containers that have boutique descriptors. There's actually, tens and tens of those already existing on Zenodo. So it's very easy to grab your pipeline that has a boutique container, and if not, then yes, there's a little bit of effort to make a boutique descriptor, but that's worth doing for like standardizing the launch of those things. It's as you've seen, like once you've done that, if you have a boutique descriptor, then launching and tracking what is happening is just one command line, and it's so that's the philosophy of that project is a little bit different from I think others.
If I can add to that, one of the questions we've received in the past is like, I kind of already have something. I'm interested in some parts of what you presented, but maybe not all of it because I already did some parts. Like I don't have this data, but I already have derivatives. That's an example that we saw recently with some collaborators. And what we helped them do, well, that was part of a kind of bigger effort to also bitsify their data. So we did that, but also they already had free surfer results. So then we just, and it was very interesting to see that it was, I think, fairly easy. What we did is create a symbolic link from the derivatives, FMR prep, and then their version was like 5.3 to whatever they had their free surfer results. I think I said FMR prep, whatever. Free surfer results, and then we took one of the tracker configuration files that we had to modify a little bit because we didn't have exactly the files that we had too many files. Free surfer 5 did not produce all of these files, and then we ran the tracker, and then it worked, and then they could see it on the dashboard. And they were very happy about that. And it was took maybe 10 minutes.
Yeah, so it's a place where you can hack, but it's I think it's an environment where you have the tools, everything. Like it's providing you with the tools and the environment to grow your own thing. It's yeah. Who is processing the data sets? 2, 3, 4, 5. Many data sets.
Yeah, I wanted to say that we're kind of doing some in-house analyses of statistical maps. And we've been thinking about organization at the study level. So I'm just really excited to kind of follow in the philosophy that you guys have come up with from the organization study to the processing and description and all that stuff. It sounds very useful.
Yeah, and again, if all goes well, this is going to be Bitsman too.
2.0.
2.0. It's really using bits at the moment, and we're part also of the bits phenotypic data, bits phenotype, working group and all those things. But the idea is to make that as much as possible something that can be followed by the community. It's complex because you have to agree with many people, and it's and also I think in the neuroimaging community, in the bits community, there's a bit of a feeling that everything should be in bits. The world is a bit larger. I don't think the genomic people will actually put their stuff in bits. So it has to be more like a study level kind of organization. So that organization of I'm sure it's not perfect. It can be like but it's a study level thing. Hopefully we really fully align with bits and at the moment it's hard to know, and everything has to be source files or and it's a bit clunky and it's difficult to convince people to do this. So we're trying to make really sure that I think Nikki is really strong on that, is making sure that it makes sense. So when you read the set of directories, you kind of understand. You don't think, oh, why is this thing inside that thing? As least as possible, at least. And so yeah, a bit of the let's say interaction with people working which don't have all those possibly baggage of knowledge. So it's easier to adopt and relate to.
So there is a raised hand online.
Oh,
Actually,
yeah, please.
Hi there. I just wanted to say, first of all, like that was a really fascinating presentation. I loved it. I think that what you guys are doing is so, so important with like data lineage. And I think it's like really obvious to people like, oh, you have a pipeline, you want to track the different version, but then you also get into like tracking different versions of the data that were processed in different ways. I feel like we should chat more maybe after this, but I'm working on something very, very similar. And so it was just really cool to like hear you guys coming up with like a very similar framework and approaching it from, yeah, like a different angle, but very similar concepts that keep coming up. And like even what you mentioned about how like, you know, you have this concept of like a pipeline and a pipeline version, but then the command line arguments can change your outputs in a very meaningful way. And that's something that we've encountered as well. And so it's really cool to hear that you guys like solved that with the JSON file. Like for us, we were looking at computing like a checksum that included the command and the pipeline name and version, and then having that checksum and then trying to like use that as a way to determine like if the pipeline outputs would be the same. And then also we got into this like whole thing about, I think I noticed when you write files into like the derivatives folder, you do like scoping by like the pipeline name and then the pipeline version. But then in theory, like if you change the command line arguments, I think that the whole folder would like get overwritten. So then you kind of like lose those data, like that data that was processed the first time if you change those command line arguments. Like it's just, yeah, it's really cool to like see what you guys have created. So it's yeah, it looks very useful, and I really hope that people like adopt it. And it sounds like a really cool project. But yeah, we should connect again later. Oh, my question was sorry. My question was whether like this tool can be run like can you kind of hook it up to different backends? Like, can you run this on your high performance like computing cluster? Can you run it on this on AWS, on Google Cloud? Like, does it play well, or is it more of just like a local thing that you would use to run subjects?
right now it's a Python package. You can install it with, well, from the GitHub, actually, we haven't published it on PyPy yet, but that's like very high on the priority list. So I guess anywhere where you could install a Python package, you would be able to run it. Yeah, if that answers your question.
And you're running it on PHP.
Yeah, exactly. I mean, the thing we have, I am running it on an HPC currently, which is where I had the demo. But I can also have it locally, which I did in case the HPC crashed or something, or was unavailable during this time, which would have been inconvenient. But yeah, I mean, I tried that last night and it was working locally. So yeah, I think we do want. I think there are some constraints possibly, but it's stuff that we are working on currently. But yeah, please reach out on Slack or through email or something. I would definitely love to talk about yeah, kind of, yeah.
And
Yeah,
also,
for sure. Sounds good.
you haven't mentioned, Michelle, that there's a mechanism that when a new subject appears in the data set, then the pipelines that are in the manifest in the config file will be rerun on that new subject.
Yeah, that's something we're
There's
working on.
a continuous aspect to that to the
Okay, yeah. If there's nothing else, it is a little bit past 5.